Okay, students, right now I'm going to debrief the structural elucidation exercise 2 which you guys did last week. Okay, it's a pretty long question, so I will perhaps change the format of the debrief. Instead of typing the information and deduction, I will just straight away use the ChemDraw and then maybe annotate a little bit here and there. Okay, so I will largely be referring to the paragraphs given. Okay, so it begins with a unstable oil, so it's PN. It has this particular molecular formula. So if you calculate the degree of unsaturation, you realize that it is actually the value is actually 4. Normally within your curriculum, 4 degree of unsaturation kind of means that it contains a benzene ring. But obviously, having 5 carbon and without any extra information, it's really difficult to draw a benzene ring. And then now you have 2 extra oxygen as well. Okay. Anyway, the question move on, and then you realize that PN takes on a relatively unique functional group. Okay. So it was mentioned that it can easily be hydrolyzed by acid or bases. Okay. So without actually going into further details, right? You don't learn a lot of functional group that can be hydrolyzed. Okay, and it was mentioned that you get A with the molecular formula C5H6O3. So the degree of unsaturation actually reduces from 4 to 3. And if you take the difference between these two formulas, right, you realize that a H2O is being added. So it's indeed some form of hydrolysis. Since PN contains only O, you can make a prediction that maybe it contains an ester. Okay, and then yeah, so I'm going to put this information in. So maybe an ester. Okay, so PN is likely to be an ester, so I'm just going to annotate this in blue. Okay, and then if you read on further, there are other pieces of information like, oh, okay, unlike PN, A dissolves with effervescence in sodium bicarbonate solutions and be converted to be a 2,4-dinitrophenolhydrazone. This is a new way of saying that it can react with 2,4-dinitrophenolhydrazine. Okay, it's a I don't think you have seen this kind of language before lah. Okay, now there is a very important difference in terms of functional group between PN and A, because you realize that PN cannot dissolve with effervescence. That means that PN does not have a carboxylic acid functional group. So you can take that off the checklist, and therefore esters might be a good choice. Of course, there are other functional group present in PN. Okay, obviously, because ester only contribute 1 degree of unsaturation. Okay, and then now they tell you that PN can dissolve with effervescence in A can dissolve with effervescence in sodium bicarbonate solutions, right? So this is actually trying to tell you that A contains carboxylic acid, right? And then can be converted into 2,4-dinitrophenolhydrazone. So therefore, these are 2 pretty important clue that is given to you. So I think we need to make good use of it. Okay, and then NaHCO3, and then this is CO2 released. Okay, and then after that positive test. Okay, I'm just going to do very short annotation, okay, because the main thing is the thought process behind getting the answers. Okay, and then they give you further information. For example, on treatment with hydrogen in the presence of platinum, PN gives B. Okay, now again, this is a relatively interesting clue. Okay, now I'm just going to put it in here, just right below. Gives you B. Oops. Okay, and then now I'm not sure whether you notice something about B, but in terms of molecular formula, there's an increase in 4 H's. Okay, so there's an increase in 4 H's. So what does increase in 4 H's is trying to tell you? This is catalytic hydrogenation. Okay, catalytic hydrogenation. Increase in 4H. Okay, this is definitely a very big clue that you cannot miss. Okay, so this indirectly tells you that PN is likely to contain 2 CC double bond. Very important clue that you definitely cannot miss out. Okay, now isn't this quite amazing? You have an ester, you have 2 CC double bond. Okay, so actually you don't have a lot of choice. Those of you who have done it pretty extensively, you realize you don't have a lot of choice. And then they tell you that P does not dissolve in sodium bicarbonate solution, but does so in sodium hydroxide solution. Acidifying it give you acid C. Okay, so acid C has this formula. Okay, so again, okay, so you have so acid C is thus likely to be a carboxylic acid. Okay, and then okay, so this is acid C. Then so this is can I also, I mean, I would say that although they try to sound bombastic, right, but essentially this is hydrolysis. Do you realize it? You see, you look at the language, does not dissolve in sodium bicarbonate solution means does not contain carboxylic acid group, does so in sodium hydroxide, and then acidifying it give an acid. So essentially this is hydrolysis. Okay, but one important aspect that is mentioned here that does not dissolve in sodium bicarbonate, right? So you can now easily say that B does not contain carboxylic acid functional group. Okay, right? I think this is very important. Oh, I think earlier on I forgot to just write somewhere here that A actually contains carboxylic acid functional group. Okay, I think I've missed this out. Contains carboxylic acid functional group. Okay, and since it gives a positive test with 2,4-dinitrophenylhydrazine. Okay, so that means that it either contains a ketone or aldehyde. Okay, but later on you realize that it is likely to be the former. Okay. Okay, right. Okay. Okay, so now I will just move on to the question. Okay. Which on standing reverts back to B. This is pretty interesting. Okay, which on standing reverts back to B. Okay, so I'm just going to just draw it like this. Okay, and then I'm going to shift this down. Okay, so I put here on standing. On standing reverts back means that it's self-hydrolyzed. Okay, so sorry, not self-hydrolyzed. It undergoes some form of a condensation reaction. Okay, back. Okay. Then after that, when C is treated with sodium hydroxide and iodine, right, it gives a yellow PPT D. Okay, now pretty important. I treat C with aqueous alkaline iodine. It gives yellow PPT and D. Okay, so I need to this is the iodoform test, which most of you are familiar with. So again, aqueous alkaline iodine, I2 in NaOH. Okay, then it gives you the yellow PPT, which is CHI3, and then plus D. Okay, then let me just copy the formula of D over, and then I just dump it here. Okay, and okay, I think everything should be pretty fine. I know that many of you might have a bit of issue in drawing it, but it doesn't matter. Okay, and then they mentioned that D evolved a gas from sodium carbonate solution. Okay, so which means D is a carboxylic acid. And looking at the degree of unsaturation, if you look at the degree of unsaturation of D, right, it's actually 10. 10 minus 6 divided by 2 is 2. Okay, you have 4 oxygen. So D is likely to contain 2 carboxylic acid functional group. Okay, and then which is verified by the fact that it reacts with sodium bicarbonate solution. And then they mentioned that D also reacts with sodium hydroxide, and then they give you the mass of D required to neutralize 10 cubic centimeters of blah 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 barium hydroxide. And then this is basically to ask you to perform a stoichiometric calculation, and you realize that the stoichiometric ratio between D and barium hydroxide is actually 1:1, because barium hydroxide is a diacidic base. Okay, remember this. Okay, don't be tricked. But D can be obtained by treating 1,3-hexyl cyclohexadiene with KMNO4. Okay, so this again is a very, very important clue, which we don't want to miss. Okay, but actually they need not give you this clue to solve it, but I think they are quite kind, they give it to you. Okay, so this was an old Cambridge question, by the way. Okay, so like this, and then after that arrow come in here, and then you get this. So so this is an oxidation, oxidative cleavage to be specific. Okay, so now I will only refer back to the question as and when I need to. So now I will largely focus on the problem solving over here. Okay, so now upon hydrolysis, to give you this, right, you realize that C contains 1 degree of unsaturation. Okay, and C actually comes from B. So can I then say that in this case, right, C contains carboxylic acid? Okay, so now and a group where we call a methyl alcohol, but we avoid using this term sometimes, so we just put it like this. As okay, so this particular structural features, a CH bracket OH CH3 as a structural features. Okay, and with this in mind, I think you can easily tell me what D is. Okay, so I'm going to draw D out pretty easily. Okay, I'm just going to put in the oxygen. And that's it, I guess. Okay, so this is D. Okay, I'm just going to just put it in red. Okay, I hope you guys are okay that D looks like this. And C, again, if you just work backwards lah, I think you can easily be convinced that this is C. Okay, right? I mean, either side, either one will do lah. Doesn't really matter which side you use. And if you can get C, you definitely can get B. Okay, so B is likely to be a cyclic ester. Okay, then how many membered ring? We can count here. 1, 2, 3, 4, 5. Okay, it's a 5-membered ring, cyclic esters. So we can do it like this. Okay, and then right now we just need to put in the oxygen. Okay, so yeah, so this should be B. Okay, if you are worried that you make a mistake, you can always number your carbon, as I often share with you this pretty important technique. Okay, actually numbering always helps to minimize mistakes. Okay, so it's something that even a professional does it, so you guys as and when necessary. Okay, so I'm just going to paste this whole thing over, and then you realize that everything fits in pretty nicely, and numbering carbon at an early stage prevent unnecessary careless mistake. Okay, right? Okay, so that will be B. Okay, but to get PN is difficult, right? Straight away to get PN is difficult. But my question to all of you now would be, right, how are you going to incorporate the CC double bond in PN such that it satisfies the molecular formula? So where can the CC double bond be? Okay, now some of you might be wondering whether you can have a triple bond or this, but I can easily tell you that a triple bond is definitely out for a cyclic system involving 5 carbon only. Okay, so I'm not sure whether you agree with me, but at the very first stage, I can only put my double bond here and here. Okay, that will really be the simplest answer you can give, to be really honest. Some of you might be thinking, can I have carbon double bond 4 3 and then 2 1? Again, it's the same thing. Okay, if you try to have a CC double bond 4 3 and 2, right, you'll notice that your carbon number 3 is necessarily an sp hybridized carbon. So you need to ask yourself this very important question: can you have sp hybridized carbon, okay, in a 5-member ring like this? Is it possible? Okay, if your answer is no, you want to force a linear structure in a 5-member ring, in that case, I don't think you should ever propose that. Okay, so this will be the best answer. We can double check, not to worry, not to rush things. Okay, how do we double check? When we hydrolyze this, that will be the contentious part, I will believe. If I hydrolyze, what will A be? Okay, so I'm going to attempt to draw A now, which I'm going to maybe put in another color. Now, if I hydrolyze this, right, the most sensible answer you can give is what I've drawn here. Okay, so this will be the most sensible answer you can give. The one I've drawn in pink on the right. Okay, what do you notice? It fits the carboxylic acid. Okay, but it doesn't have ketones or aldehydes. Okay, why does it fit carboxylic acid? Because CO2 is released. Okay, the only part that doesn't fit is the 2,4-dinitrophenolhydrazine test. But we can easily solve that particular problem, because do you realize something unique about this structure? Going to indicate in maybe black will be easier. Okay, this particular structure is actually not stable, okay, under ordinary condition. So it will immediately become a ketone. So if it becomes a ketone, it looks like this. Oops, I think I need to click it properly. Okay, so this is the ketone that it becomes. So therefore, A looks like this. Okay, so this is A, and it fits every single piece of information. Okay, right? So with all this, I think I have managed to explain to you most, if not all, the chemistry. I don't think I have not covered anything. And if you have any other issues, you can always let me know. Okay, but I guess this will be the kind of questions that you would expect, or this might be the most difficult kind of question you expect for a respectable H2 paper. And we will give you, or rather I will give you more practice in the days to come.